Welcome to a lesson on how to conduct a hypothesis test comparing two independent population proportions. When conducting a hypothesis test that compares two independent population proportions, the following characteristics should be present. Number one, the two independent samples are simple random samples that are independent. Two, the number of successes is at least 5, and the number of failures is at least 5 for each of the samples. Three, growing literature states that the population must be at least 10 or 20 times the size of the sample. This keeps each population from being oversampled and causing incorrect results. Comparing two proportions, like comparing two means, is common. If the two estimated proportions are different, it may be due to a difference in the populations, or it may be due to chance. A hypothesis test can help determine if a difference in the estimated proportions reflects a difference in the population proportions. The difference of two proportions follows an approximate normal distribution. Generally, the null hypothesis states that the two proportions are the same, meaning P sub A equals P sub B. To conduct the test, we use a pooled proportion, P sub C. So on this screen, we have the formula for the pooled proportion. Next, the difference of the proportions has an approximate normal distribution. The test statistic is a z-score, and we can calculate the z-score by hand, which we'll see later using this formula here. Let's take a look at an example. Two types of medications for hives are being tested to determine if there is a difference in the proportions of adult patient reactions. 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. 12 out of another random sample of 200 adults given medication B still had hives 30 minutes after taking the medication. Is there a difference in the proportions of adults who did not react after 30 minutes? Test at a 1% level of significance. Let's first state the given information. Because 20 out of a random sample of 200 adults given medication A still had hives after 30 minutes, X sub A, the number of successes, is 20, N sub A, the sample size, is 200, and therefore the sample proportion P prime sub A is equal to 20 divided by 200, or 0.1. And then for medication B, X sub B is 12, N sub B is 200, and therefore P prime sub B is 0.06. Because the level of significance is 1%, alpha is equal to 0.01. And now because we're testing to see whether there's a difference in the proportions, the alternative hypothesis is P sub A doesn't equal P sub B, and therefore the null hypothesis is the proportions are equal, P sub A equals P sub B. We can also state the alternative hypothesis as P sub A minus P sub B doesn't equal 0, and the null hypothesis as P sub A minus P sub B equals 0. Over here, let's calculate the pooled proportion, which is shown below. The pooled proportion is equal to 0.08, and 1 minus the pooled proportion is equal to 0.92. Next, we'll find the z-score and p-value using the TID4, so we won't need all the information shown here. We will, though, when finding the z-score by hand. So going to the TID4, we press Stat, right arrow to Tests, select option 6, 2-prop z-test. I've already entered the information here. X sub 1 is 20, down. N sub 1 is 200, down. X sub 2 is 12, down. N sub 2 is 200, down. We're testing to see whether P sub A doesn't equal P sub B. We select doesn't equal, which I've already done. Arrow down to calculate. Press enter. We have a z-score of approximately 1.4744 and a p-value of approximately 0.1404. Let's go ahead and record this information. If we look at the distribution shown below, if the proportions are equal, the difference is 0, which is why we have 0 at the center of the distribution. The difference of the sample proportions is 0.04, which is why we have 0.04 on the right and negative 0.04 on the left. And therefore the p-value is the total area of the shaded region to the right and left, and therefore each area is equal to half of the p-value, which we can see is approximately 0.0702. So we can also say the p-value is equal to the probability that the difference of the proportions is less than or equal to negative 0.04 or greater than or equal to 0.04. And now let's take a closer look at determining the z-score by hand. If we were going to conduct this test by hand, we would take the value of alpha of 0.01, recognize we have a two-tailed test, and determine the corresponding z-scores, which I've already done here. Notice the z-scores are 2.58 and negative 2.58. Next, we would calculate the z-score using the formula shown here at the bottom, which gives us a z-score of approximately 1.4744, which matches the value from the TID4. But notice how this z-score is not in the rejection region. The z-score would be approximately here. Because it's not in the rejection region, we do not reject the null hypothesis. But let's also draw the same conclusion by comparing alpha and the p-value. Notice how the p-value is high compared to alpha, and when the p-value is high, the null must fly, or more formally because the p-value is greater than alpha, or because alpha is less than the p-value, we do not reject the null hypothesis. Which means, in conclusion, at a 1% level of significance from the sample data, there is not sufficient evidence to conclude that there is a difference in the proportions of adult patients who did not react after 30 minutes to medication A and medication B. I hope you found this helpful.